Hello everyone. So in this video, we will be discussing unit conversion. So we will learn how you can convert a unit which has the same base unit, but a different prefix. So that's what we're going to be discussing in this video. Okay. So we'll start with some of the basic units that are used. For example, the base unit that you use, for example, for measuring how heavy or light something is, the unit you use is grams, right? But you must have come across the modification of the unit gram where we actually put a prefix in the front. So you might have seen mg, which stands for milligram, or you have, different prefixes that can be added. So you could add kg, which stands for kilogram. You have dg, which stands for decigram. So all these different prefixes, we want to learn how to do conversions when you have the same base unit. How do we change the prefix? Okay, so that's what we're going to learn. So to get started, we want to know what do different prefixes actually mean. Okay, so to get started, we will see that I'm going to put just the base unit for right now. So G stands for grams, right? And it has no prefix right now. Now, if we go towards the smaller units, we can actually put um, decigrams. So we want to know what decigram is. So guys, DG, this stands for deci, grams. Now, of course, if you replace this G with L will mean you're talking about liters. If you put M, you're talking about meter. So you can change these base units, but your prefix meaning stays the same. So guys, when you put small d in front of any unit, you're trying to say that means it stands for deci, and deci basically means it's 1/10, and 1/10 means 10 to the power -1. Okay, you can think of that as this is equivalent to 0.1. Okay, so it's 1/10 of a 1, right? So that's deci. If you want to go smaller than deci, then the unit we get next is C, and C here stands for centi. Okay, the gram stays the same. So centi, what is centi, guys? Centi is now 10 to the power -2. So now this is 0.01, right? So this is 100th, right? So this is 1 divided by 100. The deci, this was 1 divided by just 10, right? So deci, and then you have a smaller unit, centi. Now, what is smaller than centi? So it's small m. So if you see small m, it means milli, and milli. So if you have a milli sitting in front of G, you call it milligrams. So milligrams is 1,000. So this is 10 for -3. Okay, so this will be 0.001. So 1/1,000, right? So you're getting smaller and smaller with these prefixes. Okay, so now what's smaller than milli? Okay, so it's smaller than milli, you get this mu, and guys, mu, this is like a u, and this here is 10 to the power of -6. Okay, so this is micrograms, and micro means 10 to the power -6. Okay, so now this is quite a bit smaller. This is a millionth small, right? What is next after micro? Where we go next? It's ng, and n here stands for nano. Okay, nano is 10 to the power -9. Okay, so we will be going over all these different prefixes. So we want to remember these prefixes so that we can do the conversions easily. What we're going to learn is how to use these prefixes. What we're going to learn later on in this video. Okay. All right. So N is nano. After nano, we have P, and this P here stands for pico. Okay. Okay. And pico, what do you notice, guys, so far? Do you notice that the first 3 units that we learned, the difference was of 1. So -1 became -2. So there's a decline of 1. And -2 became -3, again, decline of 1. After that, do you notice that we're declining by 3? So -3 is becoming -6, and -6 is becoming -9. So what do you guess? What will be the next number? So if you remove 3 from -9, it becomes -12. Okay. So this is the smallest unit that we want to be aware of, the smallest prefix that you put in front of a base unit. Okay, so now guys, we're going to look at the bigger side. So just like we have DG, which stands for deci, the next we want to learn is called deca. Okay, and this and deca, it's either shown by a capital D, so you either call it decagrams like that, or you're going to see small d, small a, and then a G. So DA or capital D is the same thing. Of course, you're showing it small d, small a, just to differentiate it from just small d. Small d means deci, but DA, that means deca. Okay, now deca, as you guys might guess, this guy is going to be 10 to the power 1. Okay, so now this is, again, it is 10 times bigger than having no prefix. Okay, now keep one thing in mind, guys. Since you don't have any prefix here, you see this is blank, no prefix. So guys, when you do not have any prefix or no prefix actually means that there's nothing in the front. Nothing in the front means you're multiplying the grams with just 1, because then the gram stays the gram. The unit stays the same if you multiply it with 1, right? So if I want to write 1 here, but with the exponent and the power, what should I write that as? I will be writing that as 10 to the power 0. Okay, so this will be significant later on when we're going to learn how to use this table to do the unit conversion. So 10 to the power 0 is actually equivalent to 1, right? So let's keep moving. Okay, so after a deca, where do we go next? After deca, what we have is hecta. Okay, hecta is H. So hectagrams, this will be 10 to the power 2. Okay, so 10 to the power 2, this is like 100, and 10 to the power 1 was 10 times. 10 to the power 2 is 100 times. Okay, now what's bigger than hecta? You have kilo. So kilo is next. Kilo, the abbreviation is K, so kg for kilograms. This is 10 to the power 3. So you guys actually notice that the pattern is the same. You go -1, -2, -3, and then you go 1, 2, and 3. So again, the numbers are working the same way. Okay, so what's next? What do you guys think? What was the next number? Next number, do you remember again? From -3, we went to -6. So from +3, we go to +6. Okay, now what is this called? What do you call it when you have 10 to the power 6? The unit, the prefix is mega, and the abbreviation is capital M. So if I have to write megagrams, this is how I'm going to write that. Okay, so again, notice that capital M and small m, there's a difference. Small m is milli, it's actually 10 to the power -3. On the other hand, capital M is mega, that's 10 to the power 6. Okay, all right. So after mega, now mega, usually you never use it in front of grams. Mega is used very commonly with something you must be very familiar with, which is the storage, like hard disk or cell phone, which is megabytes, right? So what do we have higher than mega? The number is going to be 10 to the power 9, as you can guess already. What is it called? It's called giga, right? Like we have gigabytes. The abbreviation is capital G. Okay, so if I had to write gigagrams, you're never going to come across gigagrams in real life, but this is how you would write it if you had to. Okay, now these days you must be familiar with actually a bigger prefix than giga. We now use tera, and the abbreviation for that is capital T. Okay, so if you had to write teragrams, this is how you would write it. Okay, all right. So guys, you want to keep this handy. I would personally memorize this, or if I, if I had to, I would do so many practice problems with these that I would naturally just remember them by heart. Okay, um, but you can have this. You can use it in your notes as well if you want. Okay, so guys, these are the different prefixes that we want for this class. Now, what we want to learn is how to actually do the conversion. So we will do some examples and we'll see if we can figure out how to use this table, okay? Because that's what is important. You should, of course, know how to read this table, and then secondly, how to actually make conversion factors. That's what we want to do, okay? All right, so guys, let me give you an example here. So for instance, you are given a number 9.78, and you're given that number in kilograms, and then I ask you, can you please change it into milligrams, mg? Okay, so let's say that is the question. Okay, so how should we approach this question? So as we're gonna do this problem, you might already have your own method of doing this problem. And as far as you can, if you can show the work for the methodology you use, you should be good. You can use your own method. But if you have been struggling with unit conversions like these, especially the ones where you have these prefixes, I'll highly suggest to pay attention and follow this rule, okay? Follow this methodology. Okay, so what do we want to do here? So first of all, we will write down the numbers that we're given. 9.78 kilograms is what we are given. We will set up our conversion chart like this. Now, what we will do, guys, is we will place the units here, and we will place them in such a way that we actually get rid of kilograms and we keep the milligrams, right? Because in the final answer, we don't want kilograms, we want milligrams. So guys, if the kilograms is sitting here right now, and I want to cancel this unit kilograms, then this kilograms should be put where on this chart? Should I put it on the top or should I put it in the bottom? So you should put it here in the bottom so that you can cancel it. So this is what I'm trying to say, guys. If if you have kilograms sitting here and you want to get rid of that unit, put the same unit across it so that you can cancel it later on. Okay, so that we can get rid of that unit. Okay, that's one. The next is the unit that then you're trying to keep is what you're going to enter here. So milligrams is what will go here. So that's one thing, is to just set up your conversion chart like this. The next is to make the conversion factor. And this is the most important part, guys. How to make conversion factor. Please keep in mind that the numbers that you're seeing on the table above for kilograms and milligrams, we're going to use them, but these numbers cannot be directly just plugged in here and you and get the answer. That will give you the wrong answer. So what I'm trying to say is, if you just put 10 to the power -3 in front of milligrams and 10 to the power 3 in front of kilograms, you will not get the right answer. Okay, so what we want, guys, is to figure out how to actually synthesize or make a conversion factor out of the table given. So guys, milligrams we know is 10 to the power -3, and kilograms is 10 to the power +3. Okay, now how to make conversion factors, this is what we're going to learn. So what we're going to learn now, we're going to call this the golden rule. And this rule will have 2 points. So the first point of the golden rule is to pick or identify the larger unit and place 1, so number 1, in front of that unit, in front of the larger unit. So what I'm trying to say is, out of milligrams and kilograms, which one is a bigger unit? Is 10 to the power negative 3 bigger or 10 to the power positive 3 bigger? Obviously, 10 to the power positive 3 is bigger. So guys, kilo and milli. Kilo is the bigger unit. That's what we figured out. And what does the rule say? The rule says pick the larger unit and place one in front of the larger unit. So milligram, kilogram is the bigger unit. I'm going to put one in front of kilograms. Okay. All right. Now let's learn the second step. The second step is you will to figure out what number should go here. So like this should be 10 to the power how much? That how much is coming from rule number 2. So rule number 2 says that you need to count the number of jumps from one unit to the other, from the first unit to the second unit. Okay, so what does that mean? How many jumps is it to go from 10 to the power negative 3 to 10 to the power positive 3 is what the question is. So let's write down the number line and try to learn what we're trying to say. So if this is -1, -2, -3, -4. On the other hand, you have +1, +2, +3, +4, and there's 0 in the center. Don't forget the 0. So the question is, the rule number 2 says count the number of jumps from the first unit to the second unit. So one of the units is -3. The other unit is +3. So you just need to go and count the jumps. So this is 1, 2, 3, 4, 5, and 6 jumps. Okay, so it's 6 jumps. So the number of jumps, we got 6 jumps. That's the number you're gonna be placing here. Is that number going to be positive or negative, guys? Remember, for this golden rule, if you are putting the 1 in front of the large unit, then this number of jumps will always be positive, guys. So you want to make sure you remember this rule. This is very, very important. Always positive. Don't forget that, guys. No matter what type of conversion you're doing, whether you're going from the negative unit to the positive unit, or positive to positive, or negative to negative, does not make any difference. So what I'm trying to say, you're going from these positive numbers to the positive numbers, or positive to negatives, or negatives to positive, does not make any difference, guys. You will be putting a positive number here. The power will be positive if you're following the rule number 1, which says to put 1 in front of the bigger unit. Okay, so what number are we going to put here? So we said the number of jumps that we need is 6. The number that goes here is 6, and that number has to be positive, guys. This number is always going to be positive now, guys, if you're going to follow this rule, no matter what conversion you're going to do with these prefixes. If you're following this rule of putting 1 in front of the bigger unit, then the smaller unit will always get the positive power, the positive exponent. Okay, and there's no exception to this. So remember this. Okay, all right. So now, guys, if this makes sense, we move forward and we try to get to the answer. So we're trying to simplify this. So guys, remember the numbers that are on the top, they're getting multiplied. And then, of course, the numbers that are in the bottom, these are the numbers that you will be dividing. Okay, so for right now, you have 9.78 times 10 to the positive 6. You see the kilograms and kilograms is gone, and you're just left with milligrams. At the bottom, you just got 1, so you can ignore that. So guys, you actually got the answer. This is your answer. Okay, so just to clarify one more time, what I'm saying that you're going to be putting, so let's remember the golden rule again. If you put 1 in front of the bigger unit, then the smaller unit always gets a positive number. That's true, okay? But that does not mean that your final answer always has to be positive. That's not what we're saying. What I'm saying is, when you're synthesizing, when you're making this conversion factor, that's when this rule applies. Okay, all right. So let's do some more examples. Okay, all right. So imagine we have a number like this, and you're going from nm to micro m like that. Okay, so let's try to figure this out now. Okay, so you guys can pause the video if you like and try this problem, and then we can work on this together, okay? All right, so what are we doing here? Again, the first step is to copy paste the numbers you're given, okay? Guys, if you have been having a hard time with these unit conversion problems, then remember to follow these rules, okay? And if you're going to follow these rules, you will, if you break it into steps, it'll be easy for you to simplify these problems and work on them, okay? So the first thing is just copy paste the numbers you're given, and of course with the unit, and then set up your conversion chart like this, okay? Now, what we want next is where do we put what unit, right? Since the nanometers is sitting here, don't even think about the micrometer for right now. Just focus on the one that you're given. So the one that I'm given is nanometers, and I want to get rid of nanometers. So I must put nanometers here across so that I can cancel it, right? And of course, the only place left now for micrometers is this, okay? Now, how do we do this problem now? So once you have set up this chart, the next step is to follow this golden rule and figure out the conversion factor, right? So remember, micrometers and nanometers, what do they both mean? Micro means 10⁻⁻6, nano means 10⁻⁹. Okay. Now, once we know this fact, we need to follow the golden rule. What does the golden rule say again? Guys, if you remember the golden rule says, figure out which one is the bigger unit, first of all. So which one is bigger, micro or nano? Both are negative. One is -6, the other one is -9. It's more negative. So it's actually smaller, right? So nano is smaller. So micro is the bigger unit. So micrometer is bigger than nanometers, first of all, right? So what was the rule? Put one in front of the bigger unit. So micro versus nano, who gets the one? Micro gets the one. So micro gets the one. Okay, now nano gets what number? Of course, it's going to be getting 10 to the power something. So for all these same base unit, different prefix problems, this is how you set up the conversion factors, okay? So to make the conversion factor, you need to count the number of jumps. So the number of jumps from where to where? From micro to nano, or nano to micro, same thing. So in order to go from -6 to -9 or -9 to -6, how many jumps is that? You can figure this out in your head yourself if you want. If you don't feel comfortable, then you can draw this out and try to think about this in your head. And more of the problems you can do like this, more you'll get used to these, and you'll be able to do these in your head. Okay. All right. So we have -1, -2, -3, -4, -5, -6, -7, -8, -9. Micro is sitting at -6, and nano is sitting at -9. And we want to count the jumps. That's 1, 2, and 3 jumps. So guys, what number do I put here? I put 3. Do I put +3 or -3? Guys, if you're thinking of putting -3, literally stop your hand. Okay. You always are going to put a positive number here, no matter what type of conversion you're doing, if you're following this golden rule. Okay. So I've put 1 in front of the bigger unit. The smaller unit will always get the positive exponent. Okay. So you get 1 here and then 3 here. Now, how do you solve this now? So how do we solve this? Remember, simplify this. 43.56 times 10 to the power 2 times 1. And I have micrometers sitting on the top. And then I have 10 to the power 3 sitting at the bottom. This is where we are right now. So we need to solve this problem here. Okay. All right. So what do? We are going to simplify this. How do we, first of all, why is this not working? Something wrong. Okay, let's keep going. So so this is what we have. we are going to rewrite that 43.56 times 10 to the power 2, that times 1 can be ignored. And then I have this 10 to the power 3 sitting here in the bottom. Again, you have a couple of ways to solve a problem like this. You should make yourself comfortable enough to be able to solve the exponents without the calculator. Okay. Otherwise, plugging in exponents in the calculator, there will be many more chances of you getting it wrong when you're putting it on the calculator compared to if you just do it in your head. Okay, so remember a couple of things. So let's practice that first of all. So if I have 10 to the power a divided by 10 to the power b, how do I solve this? This is equal to 10 to the power a minus b. So when you're dividing the two exponents, you subtract their powers to simplify. If you're multiplying them, 10 to the power, if this was 10 to the power a times 10 to the power b, you will just be adding them, a plus b. You will add the powers. Okay, so guys, again, when you divide, subtract them. When you multiply, you add them. Okay, all right, what does that mean? When I divide these, I subtract them. So how does that work? So 10 to the power 2 and minus 10 to the power 3 is what you're doing. So 10 to the power 2 divided by 10 to the power 3 is equal to what? It is equal to 10 to the power 2 minus 3. What is that equal to? It's equal to -1. 2 minus 3 is -1, right? So if you solve this now, you don't need that 2 anymore here. We know already that this number is going to be -1. Okay, and then the answer will be in micrometers. Okay, so I hope this is making sense here. Okay, all right, so right now I'm not going to modify this answer, but this is not going to be the final answer. Once we're going to learn scientific notation, then we will learn once we know how to do the scientific notation, we will know that we need to change this answer. So let's do the answer right now. Make sure you watch the video for scientific notation. Okay, so when I have to change the number, so when I have to make the number a scientific notation, this decimal cannot stay at this point. The decimal must be between the first two numbers. So a number must look like this for it to be a scientific notation. Okay, so that's one thing you want to make sure you understand. Okay, so 43.56 times 10 to the power -1 micrometers. We're trying to change it into a scientific notation. So 43.56 must be changed to 4.356 to be called a scientific notation. So that's how we want scientific notations to be. The decimal should be between first two numbers, first two non-zero numbers. So 4.356. Now, have you made the number small or big? We'll decide what we'll do with this exponent. So you have made this number smaller. You have made 43.5, you have made it 4.356. You have made it smaller. So make this bigger. Make -1 bigger. Okay, so make this exponent bigger, this power bigger. So by how much? By as many places you move the decimal one place. So you have to make this one number bigger. So what is one number bigger than -1? It's actually 0. What does 10 to the power 0 actually mean? It means 1, right? So 4.356 multiplied by just 1. You guys remember 10 to the power 0 is equal to 1. So 4.356 times 1. So your answer is basically just 4.356 micrometers, and that's it. That's your answer. Don't forget the unit. Okay, so that is the answer for this. All right, now let's do another problem. I want to do a problem where we don't have a prefix in the front. Okay, so let's try a problem like that. So let me give you a number here. So 786.5 times 10 to the power 4 grams, and we want to change that to let's say milligrams. Okay, all right, so let's try this. So in this case, again, you can pause the video for right now and give this a try, okay? Okay. All right. So 786.5 times 10 to the power 4 grams and make the conversion chart. That is always our first step, okay? So just copy paste the numbers and set up the conversion chart. Now, what unit should I put here in the bottom, guys? What do you think? What number are we putting here? We want to put the same unit that is sitting here. So grams is sitting here. So I want to put a grams here and then the milligrams in the top, right? I hope that is making sense right now. Why do we put grams here? So that we can cancel it, right? That's why. Okay, now is the time to make the conversion factor. How do you make conversion factor? You see what do these units stand for. So milli, we know from, again, from our chart, milli is 10 to the power -3. Okay, so milli is 10 to the power -3. What is no prefix? Remember, guys, gram has no prefix. And remember, we have mentioned this already. It means 10 to the power 0. No prefix means that it's just 1, right? And 1 shown in the exponent form is 10 to the power 0. Okay. All right. So always remember, whenever there's no prefix, think in your mind as if you have 10 to the power 0, so that you can make a conversion factor, so that you can count the jumps when you follow the golden rule. Okay. All right. So milligram is 10 to the power -3, grams is 10 to the power 0. Okay. So now let's talk about our golden rule. The golden rule says, what does it say, guys? The golden rule says to put 1 in front of the bigger unit. Which one is bigger? Is it grams bigger or milligrams bigger? Of course, the gram is bigger, right? So gram gets the 1. So you put 1 in front of the bigger unit. The smaller, the rule number 2 says, if you're putting 1 in front of the bigger unit, the smaller unit will always get a positive exponent. What is that exponent going to be, guys? That number is going to be the number of jumps. How many jumps is it to go from 0 to -3, guys? Now I can tell from my head. From 0 to -3, if I need to make jumps, it's going to be 3 jumps. So I need to put here just 3. Do I put +3 or -3, guys, again? Again, if you're thinking of putting negative, stop your hand. This has to be positive every time. Okay? All right. So now we have our final step is to simplify this whole problem. 786.5 times 10 to the power 4 times 10 to the power 3, and then milligrams at the end, right? So this is what we got. Now, how do you solve this? 786.5. What is 10 to the power 4 times 10 to the power 3? It's 10 to the power 7. So when you multiply the exponents, you add the powers. 4 plus 3 is 7 milligrams. Again, what is wrong with this answer? The only thing wrong is we don't have the scientific notation. For it to be a scientific notation, we want to put a decimal between the first 2 non-zero numbers, right? So now what will happen to the power? Again, based off the scientific notation video, what did we learn? We learned that if you're making this number smaller, you got to make this number bigger. How much bigger will depend on how many decimal places you moved, okay? So you moved 1 and 2 decimal places to get to this answer. So again, you made this number smaller by 2 decimal places. You have to make this number bigger by 2 numbers. How do you make +7 bigger? Do you go towards the 6 and 5 side, or do you go towards 8 and 9 side? You, of course, go towards the 9 side, right? So 10 to the power 9, that will be the final answer. Okay, so that's the answer for this problem. All right, guys, that is it for this video. We'll see you guys in the next one.